Hey guys, I'm Eileen Liu and today I'm going to give a presentation on my project, Space System Engineering, and this is my midterm report. Firstly, we'll talk about the background. System engineering is an interdisciplinary approach to research. It is not dedicated to the best performance of a subsystem or components, but to the entire system and to achieve an optimal design. Through communication with professional technicians such as design specialists, system engineering can gradually transform the general initial development requirements to a practical system. And as a complex high-tech system engineering, aerospace engineering involves a variety of professional cutting-edge technologies and large capital investment, many people involved, and high risks. So, system engineering is the best way to solve these problems. And then let's do a brief analysis of some basic parts in engineering system design. I will talk about 3 parts in concept development stage. And finally, I will talk about the challenges. The first one is needs analysis. Two factors have contributed, but there are 4 steps in this part. The first one is operational analysis. Two factors have contributed to the birth and development of the aerospace engineering system. And the first is the need for people to understand the Earth from a broader perspective, and the second, with the development of science and technology, more and more advanced technologies can be utilized in aerospace engineering systems and making space missions that were previously impossible to achieve possible. Until now, people have made many progresses in the aerospace field. And second, let's talk about functional analysis. The functional analysis clarifies the functional requirements of each part of the aerospace engineering system and assign each function to the appropriate subsystems. And system engineers should firstly determine the location and function of the system and then eliminate the design solutions that cannot meet requirements. Or are technically impossible to implement. After the integration of each subsystem, the overall function of the system performance should be better than the sum of the function of each part, which means we can say it's 1 plus 1 bigger than 2. Thirdly, we will talk about feasibility definition. The two main tasks of feasibility analysis phase are to analyze the physical achievability and of system functions and to consider the cost of the system implementation. By collecting the previous data of similar functional units, the modified functional units in the new system can be evaluated reasonably. But for functional units designed using emerging cutting-edge technologies, which is often difficult to find similar functional units in existing systems, it is necessary to rely on the theoretical analysis and experimental data. And sometimes this can be unreliable. Then, if conditions permit, engineers can choose to perform a simulated environment test. To the new functional unit part. Although the evaluation of system cost is not accurate enough, it verifies that the entire system is feasible in physical implementation. And fourthly, we will talk about the last step in needs analysis, which is needs validation. The effectiveness analysis is the last and most important step in the needs analysis process. In this step, reasonable performance models of the system should be established, and the system engineer may do some evaluation, such as operational efficiency, analysis and cost efficiency analysis, and so on. The standards for effectiveness measurement vary for different system environments. But system engineers can select some of the basic characters of system effectiveness to develop measurement strategies. Then we will talk about the second part in the concept development stage, which is concept exploration. The main task of the concept exploration phase is to transform the operational-oriented system to engineering-oriented system view to facilitate the development of part of the later concept definition and the needs of the system development phase. In this part, a clear, measurable basis that can guide the construction of subsequent system physical models is formed, and when the system has updated optimization requirements, the original baseline should be taken as the starting point. And then compare the performance of new and original subsystems and do some changes. And the third part in concept development stage is concept definition. The goal of the system definition phase is to select particular configurations among the various system concept alternatives to determine the baseline for subsequent system development and construction, and trade-off study and the risk assessment are the two main tasks at this stage. And finally, we will talk about the challenges. From the perspective of engineering system design, compatibility between subsystems and components and optimize the system design under limited time and resources. And trade-offs in the process of the design are all challenges. And from the perspective of aerospace engineering, I think the difficulty to simulate the system environment and the difficulty to verify the technology used in the system. Because they are the latest and like data or something to analysis. And third, the design of the treatment plan for emergencies. Are all very challenging. And this is the end of my presentation. Thank you all for listening.